Hello folks, it's Clinton Moss here with Gunner Energy Services. I'm excited more than usual today because I'm presenting to you what I believe to be the most interesting, the most fascinating, the most intriguing magnetic ranging case study ever presented to the public. So folks, what do we have here in the background? I've got a coiled tubing drilling unit, and I'm going to use that drilling unit fully equipped with magnetic ranging technology to drill a horizontal well that passes by 5 different vertical offset wells. Okay, here they are off in the background there behind me. We're going to pass by each one of these, and I'm going to use 4 distinct, unique magnetic ranging methods to determine our exact distance and direction from each one of these vertical wells to the horizontal well as we pass by. So stay tuned, folks. We're going to go down hole and we're going to look in detail at each one of these 4 truly exciting magnetic ranging techniques. All right, folks, so here we are down hole, and this is perhaps the most exciting part of the entire case study. What we're going to demonstrate right here is how we inject current into the formation and stimulate the target. Okay, so just a reminder, we have our vertical target well right here, and you can see that the sensor is about to pass by. When it's time to take a ranging measurement, we energize and push current into the formation. You can see it being injected right now from the injection sub. As those electrons bloom into formation, they tend to preferentially collect about the target well itself. Now, when you have current that travels up and down on the target well the way that you see it right here, you'll have a resulting magnetic field, these concentric field lines that are emanating out from the target well. Well, folks, they pass right through the sensor assembly. We can sample those fields and determine an exact distance and direction to target. And just a reminder, we've accomplished that without interfering in the other well in any way. We didn't put anything in it. We didn't clamp anything onto it. This is truly axis independent magnetic ranging. All right, folks, have I got something cool to show you guys now? We're going to be looking at rotating magnet. This is the second technique that we deployed on this well, and what it involves is pretty simple. You take a magnet and you put it between the bit and the bit box of a motor. In the offset wellbore, we put a probe, and that probe is lowered via wire line, and it's going to detect the rotating magnetic field. Now, as the drill string advances, you're going to see it starting to drill across the screen here right now. The elliptical rotating magnetic field is detected by the probe, and the data is streamed to surface and used to calculate the precise distance and direction between the target well and the drilling well. So there you have it, folks. That's technique number 2 that was used on this most fascinating case study. Okay, folks, so here we have it. We're down hole, and we're going to talk about another technique that is near and dear to my heart, and that is passive magnetic ranging. I love it. Okay, why? Simplicity is beauty. Let's take a look at this. So let me set it up. We have a vertical target well, okay, and we have these magnetic fields that emanate from the target well just by virtue of the fact that that's a steel casing that you see, okay? And when you take these casings and screw them together, what it ends up looking like in a magnetic sense is a series of magnetic dipoles, okay? So here's a dipole right here. And as you notice, these field lines emanate out from the dipole, okay? Now, as we drill, okay, as the assembly advances, you're going to see it coming out right behind me, and we sweep that magnetic sensor through these fields, okay? We can sample the magnetic field with the actual directional sensor here in yellow, all right? And all that data is transmitted back to surface. Those data are used to calculate the exact distance and direction that passed by from the target well to the BHA. So there you have it, folks. That's method number 3 that was used in this application to provide precise magnetic ranging data. Okay, folks, so moving on to our 4th technique. I like this one as well. We're going to be playing some little tricks. We're going to be getting cued on this one. So this technique involves surface injection, okay? So what you see behind me are 2 vertical wells. We're zoomed out so we can see both wells. Now, we want to stimulate the target and create a magnetic signature of some sort. Here's a way to do it. We can clamp onto the target well at surface, and inject current down the well, okay? Current tends to flow down the well bores and bleed off. However, if you inject enough current at surface, there will be sufficient current downhole that can be detected. Now, you notice the two magnetic fields are a little bit different. We can do a switched direct current injection, okay? Or we can do an AC current injection. Now, when you energize with DC, you can use any industry standard probe, okay? But if we can energize AC and have this temporal quality to the magnetic field, we can use our many signal processing techniques to really tease out a small signal. So let's zoom in so we can see the BHA and watch it as it sweeps through these magnetic fields. Let's zoom in. Okay, folks, we're downhole once again, and I wanted to zoom in so we could take a real good look at how this actually transpires downhole, okay? So just a reminder, there's the target well, and we have our current that's being injected on surface, and it makes these field lines that are turning about the target well, okay? Now, look at the drill bit. Here it comes. As we drill, we're going to pass by the target well. These magnetic fields are emanating out. Now, when the sensor arrives, you can see it right here in yellow, okay? The magnetic field bathes the sensor. We can sample that in real time as we drill and collect all the information that is required to once again determine the distance and direction from that target well to the BHA at pass by. Isn't it beautiful, folks? I absolutely love this technique. It's elegant, it's simple, it works every time. All right, folks, so there you have it. This is what happens when you have a magnetic ranging nerd with multiple ranging methods and he's just let loose on a project. We tried it all worked, it gave us the results that we expect, and we're ready now to operationalize this equipment in the field at volume. So, folks, thank you so much for tuning in. If you have any questions about the case study, please feel free to reach out to Gunner Energy Services. It's been my pleasure, folks. Thanks for tuning in. See how we can, no. All right, it's the first video game I've ever played in my life. See how this goes. Let's go ranging. Going in the hole about 1,000 feet an hour, and bang! That was the easiest intersect ever.